So let's see if we can draw some constitutional isomers. The question says draw all constitutional isomers with the molecular formula C5H12. So what are constitutional isomers? Well, isomers are things that have the same molecular formula. Constitutional isomers are things that have the same molecular formula but are connected differently. So there are going to be all things that have C5H12, but these atoms are going to be put together in a different way. So carbon is going to be the main atom here, it's going to be the backbone, and the hydrogens are just going to bristle off of it like hairs. So let's see how many ways we can draw a carbon backbone. We have 5 carbons, so let's try a 5-carbon backbone, then a 4-carbon, then a 3-carbon, then a 2-carbon backbone, and draw all the different ways we can connect the atoms with those. So first, 5-carbon backbone. That's if all the carbons are just connected in a straight line. And so here that is. Now one thing to keep in mind is that all these bonds can rotate. So I drew them all horizontally, left to right, but I could have drawn them going down or going up. Because the bonds can rotate, they would still be this molecule if they're all just one attached to another in a line like this. So that's the only way we can draw a 5-carbon backbone. We don't have any carbons left. How about a 4-carbon backbone? So we draw 4 carbons. Now notice that there is a symmetry here. So anything we do to the left side of this molecule, it's the same as doing it to the right. So for example, if I add a carbon to the very end, we have 1 carbon left over, so if I add it to the very end, that really just gives me the same thing as the 5-carbon backbone that we had before. Because the bonds can bend or rotate. And so the drawings at the top are the same as the drawing at the bottom. Okay, what if I put that carbon that's left over after we make the 4-carbon backbone, that 5th carbon, if I put it on one of the middle carbons? And notice that either middle carbon is really the same because the molecule is symmetrical. If I do that, that is a new molecule. And so that is a new constitutional isomer. It's made with the same atoms, it's just connected differently. Okay. So that's the 4-carbon backbone. Let's see what we can do if we start off with a 3-carbon backbone. So here I've got my 3 carbons. That means I have 2 carbons left over that I still have to attach. Notice that this is symmetrical again. So anything I do to the left side, same as doing it to the right side. Okay, so what if I put the 2 carbons I have left on one of the ends together, like this? Well, that's really the same as the 5-carbon backbone that we started off with originally. Okay. What if I put the 2 carbons as a branch off the middle carbon? I have 2 carbons left. What if I put them together, coming off of the middle carbon, like this? Well, that's really the same as the 4-carbon backbone that we drew. The bonds are rotated a little bit, but it's the same. Okay, what if I have 2 carbons, what if I put them each individually off the center carbon, like this? That's a new molecule, and so that is our constitutional isomer for a 3-carbon backbone. Alright, last one. Let's try for a 2-carbon backbone. So we have 2 carbons. Notice that it is symmetrical down the center there. So anything I do to the right carbon is the same as doing it to the left. So I've used 2 carbons. I have 5 carbons total. What if I put the other 3 that I have left all together in a row next to the carbon on the right? Well, that gives me the 5-carbon backbone I started with. What if I put 2 carbons together and then 1 carbon as a different branch, like this? Well, that gives me the same thing as the 4-carbon backbone that I had. All right, what if I put each of the 3 carbons as a different branch, like this? Well, that gave me what I got for my 3-carbon backbone. So those are all the different possibilities for attaching those 3 extra carbons, so there's no new constitutional isomer that we get starting from a 2-carbon backbone. So these are the only 3 constitutional isomers, at least the carbon backbones for them, that we can form with 5 carbons. So now we just have to fill in the hydrogens. You know that carbon forms 4 bonds, so I'm going to make sure there are 4 lines coming off of each carbon. So that looks like that. And at the end of those lines, I'm just going to put a hydrogen. And so if you wanted to check, you would see that there are 12 hydrogens. So I'm going to do the same thing with the bottom left carbon. I'm going to draw 4 lines so you can see that there are 4 bonds around each. And then fill those in with the hydrogens. And for the one in the bottom right, make sure there are 4 lines around each carbon. And then fill those in with the hydrogens. And those are your constitutional isomers with the molecular formula, all the possible constitutional isomers for the molecular formula C5H12. If you want to see what those look like in 3 dimensions, just quickly, pictures would look like this. Those black balls are carbon atoms, the white ones are hydrogens. And there are 2 ways of visualizing molecules. One are where you draw the bonds. That's really so you can see the shape and the angles between the atoms. And the other is where you just draw the radii of the atoms. So this is the bond angle drawing, and then the radii is called a space-filled drawing. That looks like this for those same molecules.